4.5. How derivatives affect the shape of a graph. All right, we're going to start with something which is probably pretty obvious, and that is the fact that the first derivative says a lot about a function. If f prime of x is positive, greater than 0, on an interval, then the function that this derivative came from is increasing on that interval. And contrariwise, if f prime of x is less than 0, it's negative, the derivative is negative on an interval, then the function is decreasing there. Pretty obvious in a way. Let's just draw a picture though to make sure that intuition is there. So draw a graph of something. I'll make the function continuous just for simplicity. So maybe something like that. Okay. So let's look at the derivatives here. If I were to pick any particular point, right, here, for instance, and I were to draw the tangent line there, drawing the tangent line reveals the slope of the curve there. That's a little off maybe, but it's fine. Okay, so there's the tangent line. I would say here that the slope of the red tangent line is positive, right? So that would mean at this location at least that f prime of x was positive greater than 0, just like it said here in this statement. So if f prime of x is positive, I would expect the function should be increasing, and so it is, right? I see that from this point, if I try to move to the next point on the graph, I would be moving upwards, right? From left to right, I'd be moving upwards. So therefore, it is true that in this case, for this particular point, that if the slope is positive for the tangent line, which is the same as the slope of the curve, it would imply that the function is increasing as you move from left to right. I can pick another random point. I'll just pick this one here. Okay. Same thing, if I draw a tangent line there, a little more accurately than the last one, perhaps, something like that. Again, it looks like the slope is positive. So that means at this location, f prime x is positive, at least at that location. And that would imply, supposedly, that the function is increasing, and it does, right? It's still going upwards as you move from left to right. From this point onwards, it's moving upwards as soon as you move away from that point. So take another random point, maybe somewhere in here. I'll pick this one. Okay. I draw the tangent line there. Something like that. Here's the opposite. It looks like f prime of x, right? The slope of this blue line is negative. It's less than 0 there, right? That's the slope. And it's negative in this case. Where I see the slope is negative, the function is going down from left to right. Because the function is basically just following all of its slopes to the next point anyway. Right? That's one way of thinking about the slope of the curve. The slope of the curve is actually directing the curve to the next point on it. So therefore it follows that this makes perfect sense, that if the derivative is found to be positive over an interval, that the function is increasing on that interval. All the slopes here along this part of the curve are positive. Right? If you drew all the tangent lines, all the slopes would be positive. So therefore, on this interval, you see the function is increasing. And likewise here, if I were to pick a particular interval, something like this, I could see that all of the tangent line slopes would be negative along this part of the curve, and therefore along this part of the curve the slope is going downwards. It is decreasing from left to right.